Hey guys, we got another easy one, Leetcode 226 Invert Binary Tree, and this is one originally that you might have some worries about or whatever, or not quite sure about, but it's actually really easy. So let's jump in here, try to make it as simple as possible, and let's get another one going. So it states, given the root of a binary tree, invert the tree and return its root. Short and simple, so there's really nothing you can reply to the interviewer here besides, okay, I understand I'm getting a binary tree, and I just want to invert it and return, the structure of it, the root of it, however you want to say it. So diving in here to the example, the root node will stay the same, and then you're going to its child nodes here, and they're going to switch, as you can see here. So the left and the right are just trading places. So your right is going to equal the left's going to equal the right. And the next way down, so all of a sudden you'd have the 6 and the 9 over here, they're going to swap. The 1 and 3, they're going to swap. So you already know it's a tree problem, so DFS recursion comes up quite a bit, and this seems like the perfect problem for it, especially when you don't know how long these child nodes are going to be, and doing iterative really just be a little bit more work. So we're going to keep it as simple as possible here, and all you have to do, first off, we'll get our game plan going, and we know that we just want to, once we're past the root node, we just want to take what's on the left and have it equal the right, and have the right equal the left. And of course that left's going to be changed when we have it equal to right, so we are going to need a variable old previous root to keep track of what the left originally was. So that's all there is to it, and then we'll just run it recursively, and we'll just run it through all the child nodes, and then when we get out, we'll return the root, and that should spit out the opposite tree. So keeping this again as simple as possible, we're going here, and the very first thing we can do, we can do a lot of tree problems, if not root. So that means if it's null, there's just nothing to it, there's no children, whatever, we're just going to return none. There's nothing to see here, it's over with. So if that's not the case, then all we're doing is we're going to swap the children of it. So again, we need this variable previous root, so we're going to do previous root, and we can have it equal to root.left, and then what we're going to do from there is simply go root.left equals root.right, and root.right equals previous root, so what the left used to be. So all we've done is just swap their values out, and that's done for your first group of children. So once we've done that, we just need to make sure that this is going to happen for all the other children. So of course we're going to call this exact same function, so self.invert tree, and we're just going to pass in the root.left, and we're also going to do it with the children of the right node here, root.right. And then we're going to, after all that, after everything's processed and it's gotten through all these, we've gone through the entire stack, we're going to return the root. And that's about as simple as you can get right there. Should be O of n, you're just going through every single node and run the recursion on it. So it's really a very simple solution, a very simple problem. Another problem we should be very excited to get. So if you get these binary trees, these lower, easier level problems, that's something great in an interview that kind of shows off your intelligence, shows off that you know computer science concepts, but it's not overly difficult, and it's something that shouldn't have you breaking a sweat. So again, thanks guys. We'll keep pumping out the videos and keep learning these algorithms. Thanks.